Hello everyone. So I hope you had a nice Diwali, lots of family time, lots of sweets, in which I do not include son papdi. But now it's time to get back to work, and we'll start off by solving the question three sum closest. Now the name might seem very familiar, which is because it is quite similar to the problem three sum, and by extension the problem two sum. So before we get to this video, I highly recommend that you watch the videos on two sum and three sum before. And that is because not only is this question similar to threesome and the others in this category of questions, it is also built up on it. So the design of the question is such that first you solve twosome, then you build up on it, solve threesome, then you take a step forward and then solve threesome closest. So I recommend that you do that first. But if you want to challenge, continue watching the video as you are. And without further ado, let's try to understand this problem statement. So we've been given an array of integers, that is nums, and we've been given a target. We have to find three integers within this array as we've done before. But what do we need these three integers to do? We need the sum of these three integers to be closest to our target. And we have to return such a sum. So we have to test out all the combinations and we have to return whichever combination sum gives us the sum that is closest to the target, right? So we've been given some examples over here, but we'll be solving another one. And if you think you understand that example properly, I suggest that you try to dry run these two examples on your own. It will be useful for your intuition. Now, without further ado, we've been given an array. We have been given a target, that is 4. And we have to find three numbers. Let's call them A, B, and C. Their sum should be closest to our target. That target in this case is 4. So what approach can we follow to solve this particular question? So for those of you who've understood the threesome problem properly, they would get the same idea that there are two approaches, the first of which is the brute force approach. And if you've understood the threesome solution properly, you would also realize that brute force is not really the best of approaches, because what we have to do in brute force, I'll explain it briefly, not dig too much into it. We'll be taking three nested loops, right? Three loops which will be nested. The first loop will be for the first variable. Let's just put that here, for example. The second loop will start off for the second number. Similarly, the innermost loop will track the third number. And of course, the inner loop keeps moving and tests out all the numbers. Then the second number keeps moving forward. And similarly, all the combinations are tested out. And that is basically a brute force approach in very, very brief. Now, the reason why I don't want to dig into this approach is because it is quite time inefficient, because it is using three nested loops, which brings our time complexity to big O of n cube. That is rarely a good case for us, especially in questions like these. The space complexity for this approach is, of course, big O of 1, that is constant space. But because of the time complexity that we have at hand, I do not recommend this approach. The approach in itself is simple. Of course, you take one for loop, you take one variable that goes on till the very end, then you take the inner variable, let's call it j, that will start off right ahead of the first variable. This will go on, let's put it till n, that's j not I, j plus plus. Then the last loop, let's call it k, will start off right ahead of the second pointer, and that will be k, that will go on till the very end. All right. Now, of course, this can be optimized, the stopping condition, that it doesn't really have to go to n, it can stop one place before or two places before. That's, you can figure that out while you solve it if you really are interested in this approach. Just for the sake of simplicity, this is what I've written down. So basically, there are these three loops. Then you take the variables out for at all these three positions at I, j, and k. You take out their sum. You track or basically check if this sum that we've received is it the closest to our target that we've received so far. Basically, that would be the our sum minus target is the difference the smallest to exist. Of course, this has to be the absolute sum, right? Because the sum can also be negative in this case. Keep that in mind. So the absolute sum, absolute difference, is it the closest? And we keep on updating the value if it is the closest. And whenever it is coming out to be the closest, we track that. When all the combinations are tested, you return whatever is our answer. That's basically the brute force approach in very, very brief. And let's go on to the second approach now. So the second approach is what we call the three-pointer approach. And as the name suggests, we use three pointers. But before we find out what we do with the three pointers, we actually end up sorting the array. So let's get the sorted array on your screen. Now, we have three pointers in this approach. The first pointer, and keep in mind that this is again very, very similar to what there was in the question 3 sum. We've already discussed this. The iterative process will be the exact same. Of course, we'll see how to handle the difference in the two questions, but the way the pointers iterate will be almost identical. So we have three pointers over here. We'll keep the first pointer right at the beginning, and we will fix this position for the first pointer for now. As far as the rest of the other 2 pointers are concerned, the second one will be kept right next to A, and the third one will be kept at the very end of this array. That is basically how we set our positions for every combination. What we do is that we fix this. For the other two, we test out the combination. So let's have a few variables in place for us to track our answers. So for every combination, of course, we will be calculating the sum of the combination. We will check the difference that this sum has with our target. The difference will of course be an absolute difference, which basically means that whatever the sum is, we convert it to a positive value so that it is easier for us to track the closest difference, that's closest difference that we have so far. And of course, lastly, we store our answer variable. Now, for every combination, we take out the sum. So in this case, the sum would be -8. If the sum is -8, the difference between the target, which is 4, and our sum, that would be 4 minus of -8, that is 12. The question is, do we have a difference that is closest that we've encountered so far? Well, this is the first one, so we'll just keep the closest difference as it is, and that would make our answer for the moment -8. Then we have to handle three different cases. The cases would be whether this sum is less than our target, that is 4, that is T, whether our sum is greater than our target, whether our sum is equal to our target, in which case the difference would of course be 0. That is the best possible case, by the way. In that case, we don't need to check further, we just return the sum from there itself. Now let's see if we actually end up encountering this situation or not. Now the thing we have to test for now is which of these three cases are we encountering. So we have the sum as -8. This sum is definitely less than our target of 4, right? So this is the case that we have over here. What do we do when the sum is less than the target? We have to make our combination such that this sum goes one step closer to the target, right? We have to get the closest sum. So we have to move this sum to be as close to the target as possible. How do we do that? If the sum is less than the target, we have to increase the sum somehow. Now, how do we increase the sum? We can't move this variable backwards because that would just decrease the sum. I said that this position is fixed for now, so we can't move this. That only leaves this pointer for us to move in the forward direction. So we take a pointer, we move it by one position. Now keep in mind that anytime we move a pointer, we must make sure that the value that the pointer is at right now, it should not be the same as what it was previously to avoid any duplicate checks. If that is encountered, we simply move the pointer one more position and check again and keep doing that till we get a different value. Just one thing to keep in mind. Now, we test out this combination once again. This time our sum is -1. Scratch this out, our sum becomes -1. That would bring our difference to 5. Is 5 the closest difference that we have so far? What is the closest difference that we can have? The closest difference is 0. So is 5 closer to 0 than 12? Of course it is. So we update our answer as 5. And because this is the closest difference that we have so far, our current answer would become -1, which is the sum. Now, is this sum less than the target? The answer is yes. So we repeat the process. We move the second pointer forward once again. The value is different. So we check again. What is the sum in this case? The sum is exactly 0. What is the difference? The difference between 4 and 0. The difference would be exactly 4. Quite obvious. So is 4 the closest difference that we have so far? Answer is yes. So we update the answer and we update the closest difference and we update the answer to 0. Is the sum still less than target? Answer is yes. So we move the second pointer forward once again. This time we check whether the value is the same as the previous one. It is. So we have to move this one place forward once again. But whenever these two positions overlap, we can't have this combination, right? We need unique indexes as part of our answer, unique numbers. By unique numbers, I mean the elements should be at different positions in the array. So whenever that happens, we move the first pointer forward. But we of course check whether this value is the same as the one we had previously. So if it is the same, we move it by one more position. And of course, we have to reset these 2 pointers while we are at it. So the second pointer goes right next to the first pointer, and the third pointer stays at the very end of the array. And this is basically how we set the pointers up initially, and that is what we have to follow every time this first pointer is set. So we take out the new combination, the sum of which is 6. Sorry, 7. This sum is 7. The difference between 4 and 7 is -3, but we'll convert that to a positive value. As I said, it will be an absolute value. So the difference would become 3. Is this the closest that we have so far? The answer is yes. 3 is definitely closer to 0 than 4. That would update our answer to 7. Now, the important thing to note is that 7, which is our sum, it happens to be greater than our target. And if it is greater than target, we need the sum to decrease so that it becomes closer to our target. In that case, we can't move this forward. That would increase the sum, right? The first 2 pointers, we can't move them forward. In that case, we will move the third pointer backward. So we take this and move it back by one place. Of course, we check whether this new value is the same as the previous one. It is not, so we keep it as here as it is. Now, the new sum that we have is 5. The difference between 4 and 5 is -1. Converting that to a positive value, that would make the sum as 1. So the closest difference that we have so far is actually 1. So we update the closest difference, and in turn we update our answer because we need the one that has the closest difference, right? So the answer is 5 so far. And we check again whether the sum is less than the target or not. The sum is 5, it is greater than the target. So we move this pointer backward by one position. And whenever these two happen to overlap, that is where we reset the values. How do we reset them? We take the first pointer, we move it by one position. It is not at the same position as before. Then we reset the value of the second pointer right next to the first pointer, and the third pointer goes right to the very end. Then we repeat the process, and you can keep on performing this operation to see what is the best answer. In my experience, the answer should stay as 5, but of course you are welcome to continue this process to check for all the other combinations to see if I am actually right or not. And if I'm wrong, do let me know in the comment section below. Now let's quickly discuss the time complexity and the space complexity of this particular approach. So for time complexity, we perform two operations primarily. First is the sorting operation. That would take big O of n log n, then our loops. We have two nested loops. The first loop tracks variable a, the first pointer. The second loop tracks the second and the third pointers, pointer 2 and pointer 3. So these loops are nested, and that would bring our time complexity for the loops to big O of n square. So the overall complexity combining these two would be big O of n square. As far as space complexity is concerned, depends on the implementation of the sorting algorithm, which would ideally be big O of 1. It could be big O of n depending on the language and the algorithm that you're using. And that is basically your space complexity. And that is the approach that we follow to solve the question 3 sum closest. In the next video, we will be implementing this. So stay tuned and follow for more.